Alright, so I'm not here today obviously, so that's why you're watching this video. So these are the warm-up problems that I created that will get you prepared for the next quiz. The quiz is scheduled for this next week, Wednesday. So we have a couple more days. We have one more day of learning and then a review day and then the quiz. So I'd like you to pause this video to see how well you can solve these two problems. So pause the video and solve the two problems. So now let's go over them. So the first step with these is to factor. So on the numerator, check that you took out a greatest common factor. The greatest common factor on the numerator is 7x. So if I divide both by 7, I'm left with 2x plus 3. On the denominator, I can factor this, which might have been a little more challenging, but I need to figure out like what times what gives me 2x squared, so that's 2x and x, and what times what gives me 3. So I know 1 and 3, and I don't want to work with any negatives because the 5x is positive. So the combination that works for this is 3 and 1. Because if I were to recheck it, so just to check it, you would get 2x squared when you distribute it, plus 2x plus 3x plus 3. And you know you did it right because you get that 2x plus 3x equals 5. Okay, now from here I start figuring out my domain. So I set my denominators equal to 0 to solve. So I go 2x plus 3 equals 0. So when I solve for that, I get negative 3/2. So I know that my x cannot equal that because that will give me a 0 in the denominator. Another x, this can't equal, or that is not in my domain. Domain is negative 1. So check that you have those two. And this, I think, is the fun part, is you now get to divide anything out. So since we're in multiplication, I can divide out this whole sum, 2x plus 3, because 2x plus 3 divided by 2x plus 3 is 1. So that green is a giant 1. And I'm left with 7x all over x plus 1. And it's usually what you want to write where x cannot equal negative 3/2 and negative 1. And that would be your answer for that one. For the other one, this is a difference of 2 squares for the numerator. That's why I put that one on there. So that's x plus 11, x minus 11. If you want to distribute that out, that'll check out perfect. And then in the denominator, that one again is just harder to factor, so that's why I put that one on there. So the way it factors out is 4x and x, because I have a very large middle term, that 43. That's why I started with 4x and x instead of 2x and 2x. Just a little bit of strategy with that. So I know it's a negative 11. So that'll check out, I'll get a 44x and a negative 1x. So now I start working with my domain again. So I'm going to set 4x minus 1 equal to 0, x plus 11 equal to 0, and I solve for x. So for this one I get a 1/4, and this one I get negative 11. So I know my x cannot equal those values because that will give me a 0 in the denominator. Right, now I'm going to divide out any common factors. And what I'm left with then is x minus 11 over 4x minus 1, where x cannot equal 1/4 and 11. Negative 11. So that would be your answer. So hopefully you did okay. Some more challenging factoring ones. Today is very similar. What's going to kind of mess you up a little bit is maybe forgetting to come up with these domain values. So we're actually going to multiply the rational expressions. So the steps are very similar to what we did yesterday. So I'm just going to go right into it. So like number 9, we're multiplying. So we did this before. There was like a warm-up problem. I'm not exactly remember what the numbers were. It was like something like this. Instead of just multiplying across, you can cross reduce. So like 2 can go into 2 once, 2 can go into 4 twice. So then what happens is it's already reduced when you multiply across. So that's what we're going to do only with variables. So with this one, first thing you want to do is factor it. So I get what? X plus 2, x plus 1 for the first, and x minus 1. And there's a little trick with this other one. So you know I'm going to want to start dividing things out. And these two parts, right here and here, they look like almost the same, but they're just switched. So this is a little trick. If you want to have them switched, you can factor out a -1. If I factor out a -1, this one now changes to negative, and the x changes to positive, which ends up simplifying to that. So x minus 1. So that one's like something people have issues seeing, so just be careful of that one. So now that it's factored, I want to start looking at for domains. So I'm going to do anything in the denominator. I set equal to 0 to know what my x can't be, because my denominator can never equal 0. So I set each one equal to 0, so I know my x can't be 1 or -2 right now. Then I start dividing quantities out. So I have my, this is where I do my cross reducing. So before, you know, like I was reducing the 4 and the 2, I can eliminate this x plus 2, x plus 2. That's cross reducing. Then I can do this numerator and that denominator. Those are all 1s. So the green, think of it as all 1s. And then what I'm left with on the numerator, I have the -1 times x plus 1. And on the denominator, I just have a 1, so that's all I'm going to write. And then I'm going to rewrite my domain. So x can't be 1 or -2. That's my answer for that one. Number 10. This one, you just want to make sure you're doing your GCF, so I'm going to factor it. So 5a, can't really do much with, but on the denominator, I can take a 5 out. So 5 goes, if I were to redistribute this, I get 5a plus 5, which is what I started with. And then with this other one, I can factor it with 10. You get 10 times a plus 1 and then a. So now I do my domain. So I set a plus 1 equal to 0. I can set 5 equal to 0, but that's not going to help me solve anything, so you don't have to worry about that. So I get -1, well, a can't be -1. And then I have to set regular a equal to 0. So I'm not really like solving anything. I just know a can't be 0. So start with that. Now I'm going to start reducing. So don't forget that within the one fraction, like here, this is multiplication between here. 5 divided by 5 is 1. We've got an a. A divided by a is 1, and a plus 1 divided by a plus 1 is 1. So I pretty much divide out everything except on the numerator, I am left with a 10. And on the denominator, I'm left with a 1. So it's just 10. Where a can equal -1 and 0. That's our answer for that one. Because remember, in order for the simplified version to be equal to the original, they need to have the same domain. So that's why you need to make sure you state what your variables can be. Okay, so now we just get more complicated. So on the numerator, of the first one, I can factor a c out. So I'm left with c minus 3. And the denominator, this factors to c plus 5, c minus 5. Here I get c, w minus 5, no, plus 5, and then c minus 1. So I need a negative 5, but the distribute out to positive 4. And then here I need a c minus 1 and c minus 3. So you have to be pretty good at factoring, pretty efficient at it. So now I need to figure out what my domain can be. So for the first one, hopefully it will get to this point where you can see. But you set each pair equal to 0. So all of these in the denominator cannot be 0. So for the first one, I can't have it be negative 5. I can't have it be regular 5 if I were to set that equal to 0. I can't let it be 1, and I can't let it be 3. So a lot of restrictions on the domain. Once you do that, now we start dividing out, which is the fun part. So I see the c minus 1 over c minus 1, that's a 1. Then we get c minus 3, c minus 3. And then a c plus 5, c plus 5. So that seems like that is it. So now I'm left with c on the numerator, and on the denominator, c minus 5, where c cannot equal all these, 5, 1, and 3. So like even though I crossed off these, I still need to account for the fact that originally these values of c would give you a 0 in the denominator. So like even though the simplified version, it seems like that's the only one, the domain has to be same for the simplified and the original. So that's why this has to stay. So that's the answer for all of that. I see what's super annoying to me is people want to divide out the c's in the final answer. You need to do order of operations when you're doing this. These are in parentheses. You just don't write them usually, so you can't divide those out. You can't divide out anything with addition. We'll get to that later, don't worry. Okay, next one. Same thing again. You have to factor everything out, so I take out a 5. This one I can take a 3. Next one, a 7 is a GCF. Next one, a 10. And then I start figuring out my domain. So anything in the denominator cannot equal 0. So 3 and 10 you don't have to worry about, but like y plus 5, so here I'll just do it on this one. You set it equal to 0 and realize y can't equal negative 5. And then if you solve this one, y can't equal negative 4. So in your domain, that's what you have so far in these two. So then now I'm going to do the fun part, which is dividing out. So I have y plus 5, y plus 5 divide out. These are close, but not the same. And don't forget the numbers. See, I have 5 over 10 here. So I know 5 goes into 5 once, and then 5 goes into 10 twice. So you can do those things too, which is kind of nice. So on the numerator, you're left with 7 times y minus 4 all over. Now you have a 3 and a 2, so that's 6. And then y plus 4. Where y cannot equal where we have negative 5 and negative 4. Now this seems goofy to do the domain, like to rewrite it, but these get more complicated as we go, so that's why I want you to get in the habit of doing your domain right away. Okay. Next, second last one. So we're going to factor, so we get x minus 4, x minus 1, then we have difference of squares, and then x plus 4, x plus 1, and then another difference of squares. So if these are not coming fast, come in for help. I can make up problems really easy for the factoring. But you should be pretty efficient at this as far as the factoring goes. So next thing, domain x can equal what? Negative 1, 1, -3, and +3. So I set each of these equal to 0 and solve for x. So that's how I got everything in the domain. Now the fun part, we start dividing out. So x to minus 1, x minus 1, that's a 1. What else do we have? We have an x plus 1 divided by an x plus 1. And it seems like there should be more, but there aren't. So I'm going to then multiply across. So I have x minus 4 times x plus 4 all over x plus 3, x minus 3. And again, my x can equal -1, 1, 3, and -3. Answer. Okay. Last one. So this one, factor. So on the numerator, you can factor out an x. Oops, okay. Denominator. Oh, be careful with this one. Factor out the denominator. Take out a GCF. Take out a 3. Because this is nice. Does anyone see that where it's happening again? Okay. See how this is going to be the same over here? So, we're still going to have to keep factoring this, but I'm going to get a lot of canceling out here. So on this one, we'll just be x plus 4, x minus 2, negative positive 2x. And then I still have to keep factoring. So I factor this part right here, because I need those domains. That's what keeping me from doing all that right away. So I have, well, the same thing. So I need x plus 4, x minus 2, multiplication. Okay, domain. Where do we have it? So I set h equal to 0. So I would not have x equal -4, and have it equal 2, and equal -6. And that's from setting each of these equal to 0. So now I can start dividing out. So I have x plus 4, so I'll divide out to 1, x minus 2, x minus 2, and x plus 6 divided by x plus 6. So those are all 1s, and all I'm left with is just this little guy. So I have x over 3, but remember, you can have x be -4, 2, or -3, and then your answer. So the homework's listed on your rubric, so you can go ahead and start that and see if you can finish that in class. I'm going to collect everything. Well, I'll check everything off on Monday for this assignment, the one from last night and for this assignment. So you'll just get 2 check-offs on Monday. So have a good weekend, and see you Monday.